Hi everyone, here's a quick video to help you with those problems with the paths on worksheet 3.5. So here's the setup. I have a cat named Misty, and let's say she ran away. So here's my home, and here's Misty. And she's run away a couple blocks. The question would be, how many different paths are there that she could have taken? I mean, she could have run straight to the right, and then she could have run straight up. She could have run straight up and then straight to the right. She could have done some zigzag, maybe through the middle here. Or maybe she went zigzag like this. I mean, there's other paths she could have done. She could have gone to the middle and then gone in circles over and over and over. But if we include crazy paths like that, we're going to be here all day. And so we're only going to consider paths where she runs to the right or where she runs up. And the question is, how many of those paths are possible? Well, so far, you can see we've counted, looks like 4 paths, but we're missing a couple. She could have run to the right, and then she could have run straight up and then to the right. Or she could have done the same thing by running first up, then all the way to the right, and then up again. So with those 2 additional paths, it looks like we have a total of 6. And if you try to draw any more and just keep working at it and working at it, you're going to find that 6 is the final number. There's no more paths you can draw here, going from my home to where she is right now. Okay, we got the number 6, but is there a way to come up with this using a formula? Well, what we have to do is consider one of her paths. For example, maybe this blue one, where she went right, right, and then up, up. We could consider that path sort of like a word made of 4 letters, 2 rights, or 2 R's, and 2 U's. Well, how many ways are there of rearranging the letters in this word? I mean, we could put U, and then RR. It would be a different rearrangement of the letters. And in fact, if you look back on our path, the path UURR is written exactly here. Up, up, and right, right. So every rearrangement of these letters will correspond to exactly one path on the grid, which means if we can count all the rearrangements of the letters, we can count all the paths. And I mean, that's pretty straightforward. This is a word with 4 letters. There are 2 R's that are doubled up and 2 U's that are repeated. So we get 4 factorial over 2 factorial, 2 factorial, or 24 divided by 2 times 2, which equals 6. All right, now that we have a formula, we can try a more difficult question. Because if this was the setup where my home was over here and my cat Misty had escaped all the way over to here, there's no way I would want to draw all the paths. I would definitely want to use a formula. And indeed we can. We just draw an example path with 1, 2, 3, 4 rights, 1, 2, 3, 4, 5 ups. So our word, so to speak, looks like 4 R's and 5 U's. This has a total of 9 letters with 4 repeated R's and 5 repeated U's. We could write this out as 9 times 8 times 7 times 6 times 5 factorial over 4 times 3 times 2 times 1 times 5 factorial. Cancel the factorials. And then we can do a little bit of extra cancellation. 2 and 3 make 6. And the 4 will go into the 8, leaving a 2 left over. So that means we have 9 times 7, 63, and then times a 2 will be 126. So there are 126 possible paths. And of course, if you're bored on a weekend, you're welcome to try to draw them all out. But why would you? Once you've got a formula, you can solve this question nice and quick. Hopefully that helped. Thanks for watching.